Hello viewers, I remain Beatrice Christopher from Statistics Scribe. God's willing, in this tutorials I'm going to show you how to perform multiple linear regression in R. Okay, so quickly, I have a data set extracted from a course called Regression Analysis with course code STAT403 from the Ahmadu Bello University, Zaria, for the year 2023. Okay, so quickly, like in the case of simple linear regression, the first thing is enter your data into R or R Studio. So quickly, I'm using R Studio as an IDE for R. So I'm going to enter my data. All you have to do is, as usual, you define the variable using the assignment operator of your choice. So I'm concatenating it. So for y, I have 29.3, that's 293, comma 230, comma 172, comma 91, comma 113. Then I have 125, that's for y. Then enter. Then for x1, I have concatenated 1.6, I have 15.3, I have 22, I have 43, I have 33, I have 40, right? Then for x2, I have 851, I have 816, I have 1058, I have 1201, I have 1357, my bad, I have 1115, right? That's 3.15. So that's all for the data. All you have to do is verify the data. So for y here, I have 293, which is corresponding with what I have. I have 172. Here I have 91, I have 113, 125, correct. Then for x1, I have 1.6, I have 15.5. You see, I have an error here. So it means I'll have to effect this to 15.5, not 3. And you see it here, this is 15.5. So in this case here, it means I'll effect it at 15.5. I'm just trying to show you how to cross-check your work before performing the statistical analysis. Then the next is 22, which is corresponding, 43, 33, 40. Then for x2, our last variable, we have 851, which is corresponding. We have 816, we have 1058, we have 1201, we have 1357, and last but one, we have 3.15. So these are all correct now and intact. Okay, so all you have to do is you run your command. Okay, remember I'm using the R script here. If you like, you can use your R console. Permit me to expand this, that's to maximize it. So if you like, you can use your R console here, like I said in the previous video on simple linear regression analysis. Okay, so now here, if you like, you can put the function in a container. So let's say I want to create a variable called predicted. So let's say predicted defined by. So now I want to perform a linear model. So the function is lm for linear model, open bracket, linear model of what? My response variable in this case is y. So I have y on with a tilde sign, x1. Then you use the plus sign to show that it is a multiple regression. Okay, so I have x1, x2, my explanatory variables. So the next thing is to use the summary function, okay, to call the multiple linear regression output. So I want to use that, and this is summary of what our model is contained in a variable called predicted. So predicted, always remember that R is case sensitive. So all you have to do here is you can run the whole lines of codes. So this is our output here. As you can see here is our table. These are our residuals or error. Okay, there's the estimate. So this is our beta naught here for the intercept. This is our beta 1, and this is our beta 2. Okay, and these are their corresponding standard errors, t values and p values. Okay, so I hope you like this video and I hope you understand the concept behind this. Anyway, let me show you another approach should you not want to create this predicted, or should you just need the parameters. All you have to do is, what you have here is linear model of this, so you need to just call this variable which is predicted, that is containing the linear model, so you can just run it alone. So you run it alone. Can you see it here? So I have the intercept, it's this x1, that's beta 1, coefficient here is this, and x2 beta 2 coefficient is this. You see it's corresponding with this, right? So now let's say you want to run this in nested form or composite form. All you have to do is, let's say I want to copy my data, and let's say go to another line of code, say line 15. Assuming you have this data here, all you have to do is you use your summary function directly without creating this variable. So all you have to do is you use summary, open brackets, then the next thing is you call a function in a function, and the function in this case is linear model. It means you want to perform a linear model of, then your dependent variable, which is your response, in this case is y, onwards x1 and x2. So y on x1 plus x2. That's all for that. And just select your codes and run them. All right, command enter, whichever approach. If you observe, the values here are the same as the values here. Okay, so there's something I'd like you to take note. I'd like you to know that, let me show you what I mean. To know that you can either begin entering your data by entering the values of x1, or the values of x2, or the values of y. It's immaterial whether you start with y or x1 or x2. Okay, you can start with any of the three. Okay, so I hope you like this video. Kindly like, share, subscribe, and hit on the notification bell for more updates.